go. Let's get this going. There it is. You guys already know the 5 basic identities. You already know about cosecant is the inverse of sine, secant is the inverse of cosine, cotangent is the inverse of tangent. You know these 5 right off the bat. One of the things I want to show you guys is that all of these values and all these things always have in there some sort of an x or a theta or something like that. I forget to write it down 9.5 times out of 10. It's not the end of the world if you don't. Secant, 1 over cosine, and then cotangent is 1 over tangent. The other 2 are also the identities for what tangent was. Remember, we defined tangent at the beginning of this chapter when we were work with the unit circle, or excuse me, back in 13, when we worked with the unit circle, and tangent was sine over cosine. And the inverse of that was the cotangent. So you just flip the fraction. The next 3 are what becomes new to you. And what they are what we call the Pythagorean identities. What's the Pythagorean theorem?
A squared, b squared equals c squared.
Okay, so Pythagorean theorem was a squared plus b squared equals c squared, where c squared, or c is the what? The hypotenuse. So what I want to do is I want to look at it in terms of off the unit circle. So if I'm looking at this off in terms of the unit circle, if I pick any point here, that was our x and y values. Remember that? It was cosine and sine. Do we agree? So when I draw that down and draw this across, this gave us our radius. Remember that? Horizontal distance was the value of x. Do you agree? So this was our cosine part. This was our sine part. If I write out the Pythagorean theorem in terms of this, I get cosine squared, or excuse me, I'll write it as sine squared. I get sine squared plus cosine squared. That equaled our radius of the unit circle. What was the radius of the unit circle? Always 1. So what's cosine squared, or sine squared plus cosine squared going to equal? 1. That's the Pythagorean theorem in terms of sines and cosines. It's derived from using the unit circle, which we've done. So we have these what are called Pythagorean identities. Sine squared plus cosine squared equals 1. Which means I could get sine squared by itself on one side by subtracting cosine squared. Do you agree? I get sine squared would be 1 minus cosine squared. Same thing if I want to get cosine squared. It's 1 minus sine squared. You can manipulate that equation just by moving things back and forth. The other 2 that come off of this starts out, again, as the sine squared and cosine squared. Whenever you have an equation, if you do something to one side, what do you have to do to the other? Same thing. So if I divide both sides by sine, squared, excuse me. Why not? Did I keep it balanced by doing it to everything? What's sine squared divided by sine squared? What is it? 1. What's cosine squared over sine squared? Better yet, what's cosine over sine?
Tangent.
So this would be, and what's 1 over sine squared? Cosecant squared. There's another Pythagorean identity. Again, it started life as sine squared plus cosine squared. Divide everything by sine squared, you get the next one. Again, could I get cotangent squared by itself by subtracting the 1 over? And then I can just manipulate it back and forth. If I start with the same idea, instead of dividing by sine squared, if I divide everything by cosine squared, I'd get something different, wouldn't I? What's sine squared over cosine squared? Sine over cosine would be tangent. This would just be tangent squared. Cosine squared over cosine squared? And that's 1 over cosine squared then. There's your other identity. Again, I can manipulate and get tangent squared by itself just by subtracting 1 if I wanted to.
So the square to the second power, they don't cancel.
They do not.
You have a visitor.
Yeah, no, they don't. They cancel out because you have different values. Oh, sure, no problem. Would they cancel out if it was x squared over y squared? Same idea. All right. It's the same basic principle. So if you look at what we have up on the board on the right here, guys, you already knew these. You knew those 5 right away. This one's easy. And you see how we were able to derive the other ones without too much of a hassle? As long as you know those basic 6 of them, if you just write down sine squared plus cosine squared equals 1 on a piece of paper, take a second, divide both sides by sine squared. Take a second, divide both sides by cosine squared. You will get the other 2 identities. So you don't have to memorize everything. You're not going to get a note card. You're not going to get anything like that for any quiz or a test with this stuff. You'll have to be able to just use the material. It is a very simple thing to do. Like I said, you knew 5 of those things going in. The only other one I'm asking you to kind of remember is sine squared plus cosine squared. It's always going to equal 1, because that's how it's derived out of the unit circle, which gives you your radius. Now, where is all of this getting us? It's going to allow us to do the following. Simplify expressions. Again, this is kind of like a simplified problem is very similar to when you had monomials. Remember we had all those monomials multiplying with all the exponent rules and everything like that? It's very similar to that, but yet we're working with trigonometry instead. In this example here, I've got cotangent and secant. Suggestions I'm going to make here. Whenever you have stuff like that, always rewrite everything you can in terms of sines and cosines. Makes your life a lot easier. Plus, you'll start to see if certain things might cancel out. What's cotangent? It's cosine over sine. What's secant? What happens? Cosine's dropped. I get 1 over sine, which is cosecant.
This isn't squared.
Nope. Again, if they're all the same, if they have x's in both of them, don't even bother writing it. You can. I don't. I always forget it. It's correct. Like I said earlier, it's one of those things that I have a habit of forgetting because there's so many other things to write down. It's not the end-all, be-all. As long as what we're looking at here, that value of x is some angle. As long as it's the same angle, as long as it's the same letter, it's a theta, it's an alpha, it's a whatever they use for their symbol. As long as they are always the same, it doesn't matter if you write it down. Okay? And the other one, I have sine times the quantity 1 plus cotangent squared. As soon as I see something that has a squared to it with a 1 by it, I'm going to start thinking about Pythagorean identity. So I look at what I have right now. What can I rewrite 1 plus cotangent squared as? Cosecant squared. It's another idea here. What we're doing is it's just a whole bunch of substitution. This is the same thing as saying sine times cosecant squared. Cosecant squared is the same thing as saying what? In terms of sine and cosine. 1 over sine squared. So it's sine times 1 over sine squared. Yeah. Again, it's just a habit. I don't write it down. I just never write it down. It doesn't matter. As long as everything has the same x, it doesn't matter. It really doesn't. I'm just trying to shorten it up so you don't have to keep writing as you're going along. That's all. I'm just shortening it up. It's not a big deal. Okay.
Will it be, will you need to write the unit during the course?
No. Again, at this point in time, sine over sine squared becomes what? 1 over sine, which is? There's your answer. What we're doing here is we're simplifying it down, trying to get it to the no fraction, no nothing. What's the smallest way we can write this out as? It's kind of like doing a proof without knowing what your end result is or what it's going to be. It's a lot of direct substitution. What can you put in for what? And it's using the rules of the inverses to get you there. Which will allow you to do the following. Oh, sorry, wait a second. I forgot to ask, you guys have a nice break?
No.
No.
I don't want to talk to you.
I reside in course.
Alright, for the first one, can you use the
Guys, hold on.
cotangent equals
For this one here?
no, for the first one. Can you use
I could. If I did that, if I wrote it as 1 over tangent times 1 over cosine, if I got to that point, I would do the following. It's 1 over, well, tangent is sine over cosine, which turns out to wind up being a complex fraction. So it's 1 divided by sine over cosine, which is 1 times sine, excuse me, 1 cosine over sine, which is cotangent right off the bat. So what I'm doing is I'm just making my life a little bit easier by using those properties. You could go, like I said, there are many different ways to get to the simplified ways. Some ways are a little bit cleaner than others, but you will eventually get there if you do the process right. Just like you did in geometry proofs. There's many different ways to do your proofs, as long as you're using the right theorems and stuff to get there. The order didn't really matter in how you got to for the most part, but it still got you to the end result of proving something. Same idea with these things. My suggestion is whenever you have any of the inverses, cotangent, or excuse me, not inverse, a tangent or a cotangent, rewrite it in terms of sine and cosine, as long as it's not a squared one. It's only the first or second one you've seen. There's many of these things that we're going to do. Okay? Well, like I said, it's going to let you do the following.
Bill Cosby.
The sine of b divided by the tangent of b is?
Bill
Cosby.
Oh, it's cos.
Oh,
Cosine of b.
Oh.
Cos b.
Boo.
This time I will leave. Jerks. I'll leave the b in here so you get the joke. Tangent can be rewritten as what? Sine over cosine. Everybody agree?
Yes.
All right. So what happens is you do this. Sine b divided by sine b cosine b. What I did here is I rewrote it horizontally, multiply by the reciprocal, hence why you get cos b.
Well, actually, using the Y.
Not good.
Let's see if we can simplify this.
Oh. That proved to be an issue.
We have secant squared minus tangent squared. Secant squared minus tangent squared. There's no equal sign, so I can't just say equals 1. Okay? Let's rewrite this in terms of sines and cosines. Secant squared is 1 over what? Cosine. So I'm going to write this as 1 over cosine squared. Everybody okay with that?
Yeah.
Tangent squared is 1 over what?
Sine over cosine.
Do we have a common denominator?
Yes.
Okay. So can I put those together?
Wait,
What?
question. What does sine equal
I mean, what is sine equal? For what?
to? There's something equal for tangent and something
What is sine equal to? Sine would be equal to 1 over cosecant if you wanted to write it like that.
so minus sine squared that means
Right. Take a look at what happens here. These are common denominators, right? If it was 2/3 minus 1/3, you'd get 1/3. Now I have 1 over cosine minus sine squared over cosine squared. So I get 1 minus sine squared. What's 1 minus sine squared equal to? Cosine squared. So Jake, your dumb luck of the answer being 1 was right. But you can't just guess, you gotta show how you got there. Okay. Again, there's a couple of different ways to do this. This happens to be one of them. Yes, sir.
How does 1 minus sine squared equal cosine squared?
Sine squared plus cosine squared equals 1. Do you agree?
Sine squared plus cosine squared? Yeah.
Okay. So if I get cosine squared by itself, what did I have to do? Move the sine squared.
Alright.
So 1 minus sine squared is cosine squared.
Oh.
Okay.
What you're doing here is you're manipulating the trig identities. Sine squared plus cosine squared is 1. By subtracting sine squared over here, you get cosine is 1 minus sine squared.
Oh, okay.
This happens all the time.
Gotcha.
There's 2 ways to do this problem. What is secant squared in terms of Pythagorean identity?
1 over cosine.
No. Pythagorean identity. So you could have done it the other way and said tangent squared minus, oops, sorry, it's plus 1, right? Yeah. Tangent squared plus 1 minus tangent squared. What do you get? There's more than one way to do these. Yeah, go ahead.
Can you prove the tangent equals sine over cosine?
I did earlier when I did use the, we did that in chapter 13 actually, when we did the unit circle. When we worked with tangent, it was sine over cosine. It was, yeah, y over x. When you're at theta, your reference angle, opposite over adjacent, theta stuff. That's what we did. That's what we're doing here. Okay. What's the difference between these from the ones we were just doing? That doesn't matter. They have what? They have an equal sign. They're telling you what your answer will be. Put away your phone. They're telling you what your answer is going to be. They're telling you what it's going to look like when you're done. This is the most similar thing to what you guys did with proofs as what we can get. In proofs, you had your given and a proof statement. The proof statement is what you had to show. The given is what you were starting with. It's the same thing here. You just got to fill in all the blanks in the middle to make it work. Okay? So you know what your answer is going to wind up being. So as you're going through this, if you don't get that answer, you're probably doing something wrong. Whereas if you're in geometry, you're kind of sometimes BSing your way through it, because I've read some of your proofs. It does happen, you know, I know, it's what I did. Anyway, so take a look at this. It's very, very straightforward. Cosine and secant. What can you write secant as? So all you have to do when you're writing these out is cosine times 1 over cosine. Uh-oh. Done.
So can we just write down just the identity?
No, you have to show them. Good. Yes, I see.
Just click up there, verify the identities.
The
Just show our problem.
Yeah, what you're doing here is you're using the identities off of this. You're using the, what is secant? Secant's what it was.
Oh, okay.
They're not always that simple, Gun. They're not always this straightforward. Again, notice I've got tangent, cosecant, and cosine. When I have all of them written out like that, try to always show them in terms of just plain old boring sines and cosines. It's usually the easiest way to do these things. Again, tangent was what over what? So we have sine over cosine, 1 over sine, and then a cosine. Uh-oh. And you're done. Again, yes, it is very straight. It's pretty easy once you start writing it out in terms of sines and cosines. Things just drop out. But it's not always that clean. There will be times when it gets messy. For example,
I knew he was going to say that.
of course you did. Today we're going to keep things kind of straightforward. I'm not going to get too messy. They're not that bad. Well, they can be, but what is
Look at that, it's one of those satanic symbols.
it's a Greek letter.
Theta.
So cotangent plus tangent, we want it to equal cosecant times secant. Yeah, it's just, that's a weird, is that phi? Isn't that phi with this? Yeah. Phi. It's another Greek letter. It's another variable.
There's just something there.
So take a look at what we have here, guys. Does everybody see how it starts with addition, but it ends in multiplication?
Yeah.
Do we also agree that cotangent and tangent can be rewritten as fractions? Okay. What is cotangent as a fraction? Cosine over sine, and tangent is? All right. So I know that I have cosine over sine plus sine over cosine. When you're adding fractions, what do they have to have? What would the common denominator be of this? What is it? Sine times cosine. Think about it this way. If you had to do 1/2 plus 2/3, what would you do to get a denominator? Just multiply them together, right? Well, that's all you got to do here. So in order to get to make this work, your common denominator would be a sine, cosine. Fraction on the left is missing what?
Sine.
So what's cosine times cosine?
Cosine squared.
Fraction on the right is missing a what? A sine. So you get sine squared. What's cosine squared plus sine squared? 1. 1 over sine cosine. Well, what's 1 over sine?
Cosecant.
What's 1 over cosine?
Secant. Bang. Fine.
Oh, blah. There it is.
Couldn't you just, like, do like cosine?
What's that? No.
Could you?
We will.
Is that so? Wait. That's where you add 1 over sine over cosine. All right.
What's that?
Never mind.
Again, this is the general idea of where we are getting to. We're not there yet, but this will be we have more complex things to look at over the course of the next day or so. They will get nasty. They will look like this. There are some pretty. I don't know if we'll do this one. We might. It's not that bad.
Don't do it.
Anyway.
Don't do it, Kermit.
All right. Verify this one then, please. Take a minute. See if you can get through it. Start with what's on the left. Show that it equals what's on the right. Try that. Cotangent squared is what? Well, let's look at it this way. Does everybody see how they're asking you to start with a fraction and end with something with the subtraction in between it?
Yeah.
So what I want to do here is not break it into cosine squared over sine squared. The reason why I'm saying that is because cotangent squared is one of the Pythagorean identities. It's one of the Pythagorean identities. Cotangent squared is what in terms of Pythagorean identity?
Cotangent is cosecant squared minus 1.
It's cosecant squared minus 1.
Hey.
Hey!
Hey.
Does everybody agree?
Yeah.
Now, there's two parts in the numerator, one part in the denominator, which means it's the same thing as saying this.
So those three equations would be really nice to memorize.
Like I said, all you have to really know is sine squared plus cosine squared. And if you can derive the other two, you can write them out real fast. Okay? Cosecant squared over cosecant is just plain old boring cosecant. And what's 1 over cosecant? And you're verified.
The depression is really.
What's that? I'm pretty sure it's not 1 over cosine. Because the answer is supposed to be cosecant minus sine. So, guys, there's going to be multiple ways to set these things up. They're not the easiest things in the world to start with. Okay, it's going to take a while to get a hang of this. What's that? Cotangent squared. Remember, 1 plus cotangent squared is cosecant squared, which means cotangent squared is cosecant squared minus 1. This is the identity. This is just solving for cotangent squared.
Yeah, but where's the formula?
There isn't. What I've done here is that the original started with 1 plus cotangent squared. I just subtracted 1 from both sides to get cotangent squared by itself. That's all. What about this? A squared plus b squared is c squared. If I want to solve for b, what do I do? If I want to get b squared by itself, what do you do? Okay. It's the same basic idea. I'm just getting it by itself. I'm just moving it around.
There is manner. You just put like.
Yeah, like I said, there's more than one way to get there. In some ways are going to be easier than others. Some ways take 2-3 steps, other ways can take 9. Similarly with proofs. Try this one. Well, let me give you a hint on this one. What would you have to do with that denominator?
Multiply by
Wait. What is that called? When I multiply it by 1 plus the square root of 3, what is that called? The what? Yeah, but what is the... Remember the word, the term we used before, conjugate? Multiply by the conjugate? You did. Shh, gentlemen, come on. What you did here to get rid of that, like you were saying, rationalize, in order to rationalize, you multiplied by the conjugate. Because this gets rid of the radical in the denominator. Top and bottom. Similarly, we can do that with trig stuff. In order for us to do that with the trig stuff, we're going to start with sine over 1 minus cosine. If I want to get rid of the 1 minus cosine out of the denominator, I'm going to multiply by its conjugate. 1 plus cosine. Because what is this fraction equal to? It's just equal to 1. Right?
Fancy.
It's a very fancy one. Now, we have to FOIL. When I FOIL this out, I'm going to do this the long way one time. You should be able to pick up on the pattern. When I FOIL out the denominator, I'm going to get 1 minus cosine plus cosine minus cosine squared. Does everybody agree with me on that? What happens to the minus cosine and the plus cosine? They go away. So now I have sine times 1 plus cosine over 1 minus cosine squared. Back to the 1 minus cosine squared. That mirrors one of the trig identities. It equals sine squared. Okay. What happens with sine over sine squared? And aren't we verified to what we're supposed to show?
God, that's dirty.
Again, there's many ways of going about this. If you just, what's that? No. I mean, you could, but it asks you to stop there. Because you're right, you could get, when it's cosecant plus cotangent. So that would be the most simplified version, but if they ask you just to stop here, you're fine. All right, okay. Again, guys, they're giving you the starting point. They're telling you what you should end with. You have to figure out how to get there within all those steps. Gentlemen, this is the last time I'm going to ask you guys all to stop talking. We've got 10 weeks left of school. It's going to be a really long 10 weeks if I have to do this every day. Okay? Again, what they're asked, you should wind up with those answers. If you don't, you did something incorrect somewhere along the lines. Watch how you multiply out with the conjugates. That's where people will mess up. It's something that shows up from time to time. This is just a simplified. It doesn't tell you what the most simplified answer is going to be. You need to figure that out. Take a minute or so and go for it.
I actually like having the answer there.
You know, a lot of people do, because you know what it should look like, and that way you start to go off in the wrong way. You can pretty much, it's pretty quick to figure out what you're doing wrong. When you don't have, someone didn't FOIL at the start. Yeah. When you see it like that, FOIL it. Because you guys notice how it's secant plus 1, secant minus 1. You're going to get a squared term with a minus sign right away. You're going to get secant squared minus 1. What's secant squared minus 1? And you're done. What's that?
Yeah, you just hit that's what.
How'd you do it? Oh, you can't.
No, they're not gonna be that easy. Like the one that are like in
By
a
the time
square.
it's- yeah.
Like square. Inverse. There's gonna be like inverse.
Let me give you a few of these to try for tonight. We'll make this more difficult tomorrow.
With square roots.
You know, to be honest with you, these are the ones that get to be a lot more complicated. We get into some of these things. But again, it winds up being a lot of common denominators, adding, subtracting, not cross multiplying, but multiplying out. It's not that bad. It's just a lot of fraction work. There are ones that have negative angles. There are coterminal angle stuff or things we'll do. I don't know if we're going to get too involved with the negative stuff. I don't think we'll do really all that much. So this is section 14.3. It's page 853. I want you to do numbers 28, 31, 37, 44, 45, 48, and 49. Again, the reason why I'm picking and choosing some of the problems is because there are some properties that we do not really need to worry about in this class. The half angles theorems, I don't believe you even see in pre-calc, so I'm not going to bother with it. The negative angles we will talk about later. There's just there's 3 rules that are very simple to use. Okay? That's a good starting point. Get going on those. We will we'll go over them tomorrow, then I'll give you guys that worksheet that I was just showing you, and we'll start working off of those. It's fun.
When are we gonna get our quizzes back?
I have a couple of people that are left. Oh yeah, with quiz stuff. Again, I'm sorry I wasn't here on Friday. Our youngest got real sick. I did get them graded over break, but I could not enter anything into Skyward until Saturdays when everything became live again. So I put stuff in Saturday morning or around lunchtime maybe. So all in all, you guys did really well on it. To be honest with you, the mistakes that were made on the quizzes usually, if anything, you missed the A value. If the A was negative, you went the wrong direction on your graph. But let's see, all of your period was correct, all of your points and all of that stuff was correct. I would only dig you a little bit on it because you knew what you're doing, you just made an idiot mistake. Other than that, I think you guys did fairly well on it. I think the scores were pretty good. So. Okay? If you want to look online, you can pop on there now, they're there.